before we start, we have 30 minutes, so you can either listen me talking about monads, or I can play Hades for half an hour. Which you prefer? Your choice.
Play the game.
I have controller in my bag. Okay, so durable event-sourced workflow monad. If life was a game, I would expect to get an achievement in the lines of, you made a conference title purely out of almost meaningless words. But men gotta do what men gotta do. So, question to you. Who of you have seen my rants from 2022? I hope for at least a single hand. Yes, there is a single hand. Perfect. But let's start from the beginning. Because I have a little bit of history with workflows. And if you don't know what I mean by workflows, don't stress about it, we'll get to it. So, in 2018, I worked at Sony Electronics with a tool called Camunda. If you don't know what Camunda is, I'm glad for you, don't learn. A year after, we realized Camunda is not such a great tool, and we looked for alternatives. We started using something called Uber Cadence that soon after became Temporal, which is now I think the mainstream solution for workflows and durable execution. In 2020, at Swisswork, I worked on a custom solution for a workflow problem based on event sourcing. And in Q4 2022, I started ranting that everything is broken. To make it funnier, 2 years later, or almost 2 years later, we implemented another workflow solution at Swisswork, this time based on Kafka and Postgres, which is also broken. And yes, around the same time, I created the workflows for REST prototype. And now, a year after, I'm here to tell you what came out of this prototype. So, let's discuss why everything, what is a workflow? Okay. What is a workflow, right? If you strip all the fluff from it, it's like those three things: steps, state, and time. So you have a bunch of steps, they carry some state between each other, and it executes for arbitrarily long time. Days, weeks, months. Okay? And that's it. And it might have a couple different names. They are not exactly equivalent, but there is a big chance that if you're using one of those, you might be facing a workflow problem. And you might be looking for a workflow solution. And now, it's very important for you to know what kind of business problems we are facing here, solving here. So I have a few examples. So the first one, employee onboarding, someone signs a contract and you want to create accounts for that person in your system, but you want to do this 1 day before they join, right? For security reasons. So you have those two steps and quite a lot of time between them. You have food delivery, where you want to take the funds from the cart only after the food was delivered. Like, it's a bit more complicated than that, but let's keep it like that. Or you have expense reimbursement, where you want to send the funds only after it was approved by the accounting team. Okay? So those are kind of the processes that might be solved. Now, question to you. Who of you have solved this kind of problem at work? Yeah? More and more hands, yes. So that confirms my first hypothesis that this is a very common problem in software development. If you take big enough company, you will face some kind of process that has steps, state between them, and the process takes a lot of time. Now, my second hypothesis is that most of you who faced this problem built a custom solution to it. Why? Because everything is broken. So let's discuss why that's the case. But to understand why everything is broken, we have to understand what goes into a workflow solution. So we have a definition, we have so how we define the workflow, what steps it takes, we have the execution. So we run the workflow and something happens, we monitor as it happens, and then we manage it, meaning we deploy new versions and stuff like that. So that's the surface. Now, what really goes into a workflow solution, or like what is really important is, yes, the definition, but then there is understandability. If you have a process and you want a solution, like a dedicated solution, not a handcrafted one, it probably means your process is complicated. And if your process is complicated, your tool should help you understand it. You cannot just close your eyes and hope, no, it's going to be fine. We have 50 steps in some random order. We're going to manage it. No, you're not. And then there's migrations, because we are talking about processes that takes weeks, months. Okay? And this means there is a very significant chance your workflow will change when you still have running instances. So you cannot just replace something because the old flows will break. Okay, so there's a couple of tools in that solution space, but they are not good, at least to my criteria. So the first thing that I poorly named self-contained, that's like, I'm bad with naming, but a lot of those tools decided it's a good idea to force user to deploy a server of some sort. So they come with a self-contained, they come with a dedicated component you have to take as a Docker or whatever and deploy it in your infra. And this is something I don't like. I don't like added complexity when I can avoid it. The second thing is some of those tools decided you will be defining the workflow in a data format, YAML, XML, something like that. And this is terrible. Like, you don't want to define code, logic outside of code. That's why we have programming languages. And then the third thing is that the tools that did it right, so they are code first and allow you to define the workflow with code, are not declarative, meaning you cannot render upfront the shape of your workflow. And that's important for understandability. You want to see with your eyes your workflow. And even if you can read the code, your business cannot. Okay? So, and yes, there is Baker. It's a nice project coming from ING Bank. I just thought it's nice to build a little alternative. So, one more caveat. Data workflows are not our workflows. So if you think about tools like Airflow, this is a completely different problem domain, completely different solution space. Typically, tools like Airflow, they don't handle state very well. They don't handle loops very well. They don't handle process interruption. Like, if something takes a month, you might just turn down the server or something. So that's completely different problem domain. Sure, cool. So this is why workflows for us came to be. And it's composable, scalable, business-friendly library, possible only in Scala. And we'll not go into those items. I will show you the thing first. So how do we define the workflow? We start with a trait. We have WIO, because why not? And naming is hard. Workflow IO, that has input, error, and output. For now, simple. But we are Scala developers. We cannot have simple things. So it has to be a little bit more complicated. So we have also the context that carries two more types, event and the state. The state is what you can expect. I told you that we have some kind of a state. So this is how we encode the state of our workflow. It's static for the whole workflow definition. And then we have an event, because workflow for us is based on event sourcing. So all the state changes are persisted through events that then get replayed, and the current state is built when you recover. But it's still a little bit too simple. We have to complicate it a little bit more. So we added this small thing here. So in WIO, we ensure that the output is always a subtype of the state. This means whenever we produce a new value, we also produce the new state of the workflow. And that's it. Now, is that a monad? I don't know, I don't care. It does have a flat map method that you shouldn't use, and it does have pure. But verifying the loss would be very complicated, and nobody cares about that. So let's look into how you build those WIOs. First, most important step is executing code, right? You want to execute some arbitrary code, and first thing you have to do, you have to differentiate between pure and impure. Why? Because when you do the impure stuff, you return IO of event that will get persisted, and only with that event you can build the state. The pure doesn't have that constraint. It will run whenever you restart your workflow. Sequencing steps. You just define two things, one from A to B, the second one from B to C, and then you sequence them with the operator, and it has it calls and then. It has a normal variant as well, and that's it. Now, you can also do flat map, and you shouldn't. Why? Because flat map takes arbitrary function from, in that case, it would be from B to WIO, okay? And you don't want to do that because this cannot be rendered. This is not declarative. You cannot introspect that function. So it's a kind of an escape hatch in case you don't like the other alternatives. Cool. Now something more interesting. Signals. Signal is basically any kind of event signal from the outside world to the process, to the workflow. So you have the request, you have the response, and that's pretty much it. You can deliver stuff to your workflow, let's say user approval, right, in that way. Then you have timers. So you want to wait for a particular amount of time in your workflow. This is how you do it. You just have to define how you persist the start and the release of the timer, and that's it. Okay, now error handling. You have seen we have error channel. So now you define the WIO that has the error. You handle that error by defining WIO that takes state and error as input, and call handle error, and that's it. This allows you to interrupt a workflow, like take alternative path when something goes wrong. You typically in a workflow will have the main path, and then you have the alternative based on errors. But you can also interrupt the process asynchronously, meaning either through a signal or through the timer. With signal, you might want to implement something like cancellation, like you have a process, but at some point you decide, like human decides, no, we don't want to continue with that process anymore, then you implement the cancellation, the interruption with a cancellation signal, and that's it. Timer interruption is for when you want to have a timeout. Like you say, do those steps for 1 day. If nothing happens, then do something else. Okay, so those are interruptions. And there's more. I'm not going to bore you with that, but we have forks, which is like ifs, like taking conditionally different branches. We have loops, parallel paths, in case you want to wait for a couple of signals in parallel. And embedding sub-workflows that might have a different state and events. Cool. I'm going to bore you with something else. Because what you saw is pretty complicated. Like you have to deal with the persistence, with all the events. You have to define the exact logic. And that's not how you want to build the initial version of the workflow. What you want to do, you want to draft something, take this to your business, show them, and ask, is that what you wanted, right? You have some idea of what they want, but it's almost never a match with what they actually need. So Workflows for us comes with dedicated utilities for drafting a workflow. where you skip as many details as possible. You just give it a shape, define the steps, and you can render this out of this code. And then you can implement your steps one by one and refine that. Cool. Can we do direct style? No, we can't. One part of it is that defining the steps is complicated. The second thing is your steps shouldn't be lightweight. Okay? The more steps you have in the workflow, the more complexity you push there. And this layer of abstraction is meant to be understood by non-technical people, right? They are the ones who typically define the order of the steps and stuff like that. So you want to keep that simple, hence we don't make it too simple, too lightweight. Okay, that's it. We know how to define the workflow. Now let's look how can we run it. Okay? And that's not exactly hard. You just need a workflow runtime. Runtime has a single method that allows you to create an instance with some ID specific to the given runtime. And this gives you a workflow instance. What is a workflow instance? I'm glad you asked. It's once again, a rather simple interface that has a couple of methods. The first one is query state, like you can get the current state of the workflow. You can deliver a signal to a workflow, right? You can wake up the workflow. This might be a little bit confusing. The thing is, nothing will run on its own. The workflows for us is not responsible for running your stuff. You have to run your instance explicitly whenever you see fit, and this is where you call wake up. Now the steps will start executing. And you can also get the progress, the current progress of the workflow, kind of a metadata. We'll see why a little bit later. Cool, so this is a small recap. We define the workflow by constructing a WIO. We pass that WIO to create a runtime. So you can think about it as kind of a template, right? So we create a runtime, and then the runtime allows you to create instances. For example, if your process is like one process per transaction, you will have one instance per transaction. So what runtimes do we have available? First of all, we have in-memory one. This is useful either for test or for very specific scenarios where your workflows are ephemeral, right? Like you don't need persistence. It doesn't matter if something starts from the beginning. There are some rather specific use cases like that. On the opposite side of the spectrum, you have PECCO, which is, I think, the state of the art when it comes to distributed systems and event sourcing. So you can have that. Your workflows will run in memory with like passivation as you configure it. It's basically, you can get quite a good performance from that. But if that's too much, there is also a Postgres runtime that is simple or even simplistic in that sense that it just relies on the existence of a single table with the like storage of events and have a little bit Postgres-specific logic on the logs side. Like the workflows has to be locked to avoid certain issues. And there is one more that is being worked on right now, and that one is the least likely to be used by anyone, but I like it the most. I think it's the most interesting one. So if you want persistent, scalable storage, but you don't want to run a database, what you can do, you can give a path to Workflows4s, and Workflows4s will create an SQLite database on that path per workflow, meaning you will have per instance. So meaning you will have as many files as you have instances, which might sound a little bit crazy, but I like that level of craziness. So if you start thinking about it, it might make sense. Like you can layer the files into subdirectories, so you limit the limitations of the file system. You can mount the volume on the cloud so it can be shared between services. And if you reach the limitations of the file system, then you can archive the completed workflows to S3. So I don't know why someone would use that, because probably running a Postgres is easier, but I take it as personal challenge to find a use case for it. Cool. One more thing that is part of the runtime is a knock wrapper. It's a component that is responsible for waking up a workflow at a particular time. Because when you have a timer and you say, wait for 30 days, then in 30 days, something has to wake up your workflow for it to continue working. And this is why we have knock wrappers. And there is a couple of them. There is a sleeping one that is not persistent, it's in memory. On the opposite side of the spectrum, again, we have Quartz, which I think is the oldest scheduler in the JVM world. And there is a custom implementation based on the file system, so it will just create a bunch of files per wake-ups and monitor that directory. Nothing crazy about it. So you can pick any of them, and that's fine. Cool. So now you know how we define the workflow, you know how we run the workflow. Now let's talk a little bit about the visualization. So the first way to do this is BPMN. BPMN stands for Business Process Modeling Notation. It's an open standard from 2000, I don't know, 12, 14 maybe, I don't remember, which is nice. I like it, because it gives pretty clear semantics to different graphical symbols. It's like UML for workflows. The problem with BPMN is that most of the tools assume this will be created by hand. There is very limited ability to create this programmatically, or this also means there is very little auto-layouting. So if you do something crazy, the output gets messed up. That's why there is alternative visualization using Mermaid. So not as well defined, but whatever you throw at it, it will be fine. And Mermaid can track not only statically how the process looks like, but it can also render the running instance and mark all the nodes that were executed with the green color in that case, which I think is pretty cool. Who thinks it's cool? Yes, that's the amount of hands I was hoping for. Cool, one more. Because who said the visualization has to be graphical? This is another visualization, in a sense. It's a textual output for debugging. And I know it's hard to read. I don't expect you to understand what is there. The point is, you can render out your current state of the workflow to logs if you need. And there is support for it, because why not? Cool. One more thing. The web UI might be coming. So the Workflows for us, web UI, was submitted as a Google Summer of Code project. So there is a chance some poor student will have to work with me on that, and we might get a nice web UI with Tyrian created. Cool. So back to the origins. Composable, scalable, business-friendly library possible only in Scala. Let's dig a little bit into that. What it means to be composable. Workflows for us is composable because when you define the workflow, you compose WIOs from other WIOs, right? The same way we do with IOs. On the different abstraction layer, you can also compose workflows from different workflows through embedding. This is not, I have not shown you this, it's more complicated, but it is possible. It's scalable because we have runtimes that scale both up and down. You have Pecco, you have in memory. You have knock wrappers that scales up and down. You have Quartz, and you have something that just sleeps on a thread. You have sub-workflows that allows you to scale your definitions to arbitrary sizes, and you have drafts that allows you to scale definitions to as low as possible. Right? So this is a very important thing for workflows. For us, it scales not only up, it also scales down. Because one of the biggest problems with existing solutions is they're very heavyweight. It takes a lot of effort to deploy something like Camunda or Temporal and to maintain it. You don't have that problem with Workflows for S. It's business friendly because it put a lot of pressure and emphasis on visualization and progress tracking in a way that is consumable by non-technical people, right? We are in the world where the processes comes from the business. We want the business to be able to see how they were implemented. And it's a library. So we don't have any server that you have to run. You just need a storage or not. And there's no scaffolding. It's not a framework. It doesn't make any assumptions of how you structure your code or anything. You just create a runtime, create a VO, and start running your instances the way you want. And the claim is it's possible only in Scala, at least in practice. Why? Because first of all, we have Akka and Pekko, which are really state-of-the-art solutions, and I don't know of anything close to it in different ecosystems. We have culture of IOs. So if we take a random Scala developer, they will be at least semi-comfortable with IOs and distinguishing pure and impure stuff, which is important conceptually to build the workflow correctly, because you cannot have indeterministic code running in your workflow. If you look into Temporal, who has any experience with Temporal? Anyone here? Okay, couple of hands. Yes. So if you look into Temporal, that's something that they say explicitly in their docs. A lot of issues comes out of it, and this is because there is no visual or distinction, or on the type system level, the distinction between impure and pure stuff, and Temporal breaks whenever you start doing impure things. And then there is a lot of language features that Workflows for us uses to deliver what we need. Cool. Is it production ready? Yes, kind of, but it still misses a few things. So the first thing it misses is polishing. So it evolved from a prototype. There is a lot of corners being cut, a lot of rough edges that you have to deal with for now, and that we have to fix. And there is one big thing that is currently missing. It misses a strategy for evolving the workflow. So I know how to do this. I just have to sit down, implement a little bit of code, and then write quite a lot of docs on how you're supposed to handle the case where you need to deploy a new workflow while your old ones are still running. It's an important bit that has to be handled. But most of all, it needs feedback. It needs usage attempts, and that's for you. Like, if you think the project is cool, what I really need is someone telling me what is missing, what was too complicated, what was not ergonomic, and stuff like that. Without that, it's impossible to build a good solution. And if you want more, there is more. So you can watch the presentation from 2022. You can go to the docs. The docs are comprehensive. I try to document whatever lands in the library. You can go to YouTube and watch the devlog. There is a single video there. There will be the next one, hopefully next week, where I try to explain how the thing is being built. And there are Workflows for us issues. There is a couple, not many, but still a few, marked as good early issues if you want to start contributing. And most of it, finally, there is the Discord for the whole Business for Us community, where you can come and discuss the library, share feedback, ask questions, whatever. I'm there. Please come. And that's almost everything. I just want to leave you with two things. One thing is that there is hope that if you have to build a workflow at work, in a couple of months from now, or years, or maybe even tomorrow, there will be a solution that is better than everything else that is out there. But there is more. The question I ask myself quite a lot is, can this be the next gateway drug to Scala, like the killer app? And I don't know. Of course, this won't be another Spark. This won't be another Akka. But knowing how popular that problem is, and knowing how broken everything is, and knowing how much it costs to build a custom solution for that problem, I think there is a niche that we can try to occupy. The thing is, we just need to make this tool good enough for people, for it to become a motivation for people to start using Scala, because there is little alternative. Thank you.